minutes and nobody could see what I was doing. So if something happens, please speak up. Don't be afraid to. You know, I didn't mute anyone. How do I share this screen? Okay, can you see? Oh, beautiful. Good. Okay. All right. Hopefully technology will do well. All right, but basically, as you can see here, what we're doing is we're going to do more factor by grouping. Okay. Let's see what I'm doing. Okay, good. Everyone can. Okay. So basically, that's what we're going to do today. And again, this technique of factor by grouping, this is actually what you want to use when you're factoring a polynomial with 4 terms, as you can see here. There is a technique that's posted in the notes from last time, actually, which I think was actually last week because Friday class was canceled. So in that technique, the first thing you want to do is find the GCF, you know, the greatest common monomial factor of the polynomial. And now right away, you can see that there's a non-zero constant term, right? We have the 8 here. And that tells you right away you can't factor out x at all. So in that GCF, you could say, well, m is 0, which it's more precise to say the x is not there. What was I going to say? Okay. Now, if you look at the numbers here, the coefficients and the constant term, right? Well, I didn't write out the factors, but hopefully you can see that the greatest common factor among these numbers here is 2. Mostly because 2 is itself a factor of 4 and 8. Oh boy. Oh, you gotta be kidding me. Shoot. It froze my screen. Come on. Hold on. So, okay, I think it's working now. I think it froze a minute ago, so let me see if I can make this work. Can everyone see it?
Yeah.
Okay, good. But anyway, okay, so this is what we have here. So again, 2 is the greatest common factor of the numbers, the coefficient, and the constant term. So we get b is equal to 2. In other words, the GCF is just 2. So that's what happens. Okay, so we have that. Now, what we do, remember, is once you get that common factor, in this case, the GCF, the greatest common factor, you factor it out. You pull it out, in other words, right? You factor it out. But when you factor it out, what do? You divide into each of these terms. And by doing that, okay, you have to divide into each term, as you can see, right? Now, what do you get? Well, after you carry out this division, for instance, you can see, let me get to the pen, right? For instance, you can see the pen here, excuse me, the 2's here are going to cancel. That's why we get just x cubed. Here, we have 4 over 2, but that becomes just 2. Same thing over here. 4 over 2 becomes 2. 8 over 2, and that's over here. 8 over 2 becomes number 4. So we get this. So now, what do? Well, we have to factor this here. Okay, so that's what we're going to factor next. Let me just see something though. Oh, it's not sharing? Crap. Okay. All right. Okay, there we go. Now it's working. Technology. Okay. Okay, so again, we're going to factor now this thing at the bottom here, okay? This thing at the bottom, namely the x cubed minus 2x squared plus 2x minus 4. So we're going to factor that. Now again, this here, as you can see, it's a polynomial with 4 terms. So we're going to use factor by grouping. Now, how do we do that? Well, remember what we have to do is we have to, oh no. Remember what we have to do next then is, this thing's acting funny. Okay, so what we have to do next, remember, is we have to form 2 groups of 2, right? That's what we do next. We form 2 groups of 2. There we go. Okay. So the first 2 terms go in one group. The second 2 terms go in another group. Okay. Right? So then we have to handle each group individually. So for the first group, we have x cubed minus 2x squared, right? And basically, we factor each of those groups individually. I mean, essentially, we're going to take out common factors. So here, hopefully you can see here that the GCF is just going to be x squared, mostly because the smallest exponent of x is 2, right? And not only that, the coefficient here is 1. Okay, so the greatest common factor of 1 and 2, well, that's just going to be 1. I mean, 1 is the only common factor of itself. Someone have a question?
I typed it in the chat as well. Are you recording the lecture?
Yeah.
Okay.
Everything. Oh, yeah. Okay. Yeah, I didn't see the, okay. There we go. Okay. So basically what we get here is that the GCF is x squared. Again, smallest exponent of x is 2. Okay. The greatest common factor of 1 and 2 is just 1, because 1 is the only factor of 1 is 1 itself. So if you were to list the factors of 1 and 2, you would see the only common factor is 1. So we factor out x squared, and that's what I'm doing here. Okay, so we have x cubed minus 2x squared over x squared, right? We factor it out, but we have to divide as well, and that's what we're doing here. Okay, you divide into each term, as you can see. And so x cubed over x squared, well, that's just x, right? You know, you just subtract the exponents. Here, the x squares cancel, so we're left with 2. So that's what we get here. And now we do the same thing for the second group. Namely, we have 2x minus 4. And now we have to factor that. And again, we're just taking out the GCF of it. And again, notice that there's no variable here, right? Because 4 is a constant term. There's no x here. So yeah, the smallest exponent of x is 0. In other words, you're not going to factor out x at all. But notice from 2 and 4, if you were to list the factors of 2 and 4, you would get that the greatest common factor is 2 itself. Mostly because 2 is a factor of 4. So the GCF of this thing is 2. So basically, we keep on finding GCFs like crazy. And we get this. We get 2 as the GCF, and we factor it out, as you can see. Now, notice also, okay, that in parentheses here, we have something in common. In other words, we have, let me get that pen, among these 2 groups, okay,